Hi, my name is Nick Schrock. I'm the CEO of Elemental and the company behind Dagster. And first of all, I'd love to thank the organizers of this conference for inviting us and including us. It's really an honor to be here with all these other talented technologists and teams. Just a little housekeeping. There's a QR code on screen. You can use that to go into a Discord where there'll be discussion about this talk and generally about the conference. So this conference has been a series of talks where we're going through the data stack journey of a particular company that we've made up called Yukon, going through every single stage of the modern data stack with a focus on open source. And if you've been watching these in order, which I've been impressed with, you've seen Snowplow and Meltano, an open source ingestion tool, and now you're hearing from Dagster. And you will be hearing from DBT, Superset, and Grouparoo about other phases of the data stack. What's interesting is that orchestration really could have gone anywhere. It actually might have been more appropriate at the end because we are the one that orchestrates all the different technologies that we're talking about here. So how do we view Orchestrator and its relationship to the other technologies? Very narrowly defined, we believe the purpose of the orchestrator is to manage the interoperability of all the different technologies that you see in a modern data stack or platform, as you can see in the slide. These technologies depend on each other in a variety of ways. For example, you can't run DBT until data has made its way into Snowflake or another data warehouse. And your reverse ETLs, such as Grouparoo, won't have new information to load until DBT has updated its model. The orchestrator is the centralized place where you can define the dependencies between these different technologies. Therefore, it's a centralized place to learn how data flows from one point to another, and the centralized place to see operational information such as failures, logs, and history for any workflow that you're running. If someone were to ask, where do I go to look at my data stack? We believe that the orchestrator should serve as a single pane of glass to turn to, because it is the tool that invokes all the other tools. It is a natural point of centralization for operational concerns. In essence, the orchestrator is in charge of ordering and executing the arrows in this image. With the modern data stack, you can end up using a fairly small number of distinct technologies to spin up a productive analytics platform. It can be tempting to look at the slimmed down set of technologies that the modern data stack enables and envision a set of operational dependencies that just look something like this. However, even if you're using a single tool to handle a bunch of different jobs, for example, to choose an example out of nowhere, imagine you use Meltano for all your ingest, the underlying complexity of the data dependencies still remains the same. You still have to ingest from the same number of distinct sources, which might each have their own schedules and downstream dependencies. For most users, even those using just a handful of technologies, this is not a realistic picture, and it greatly oversimplifies their reality. In some ways, the modern data stack as it's used has been a step backwards for some people. Just as a brief history of how workflow engines came to be, in the beginning, there were overlapping crons, where you would set a cron job to run, say, at midnight every night. And then if you had a job that depended on that upstream one, you would guess and say like, hey, I believe that those jobs upstream will never take more than 3 hours, so we'll start the next one at 3 a.m. And that was extremely fragile and error prone. And that's why workflow engines were invented. Instead of hoping and praying with overlapping cron schedules, you simply encoded the dependencies in a way that didn't ever screw up in the ideal world. Well, lots of modern data stack practitioners have actually somewhat de-evolved in this manner. They might set up managed services with an ingest tool, with a transform tool, with a reverse ETL tool, and be back to a world with overlapping cron jobs. And while in here, the crouched human with a computer is more efficient than the ape without the computer, they still are crouched. They still have regressed effectively to the state where they're dealing with a lot of operational fragility. And that's where Orchestrator comes into play. So we believe that for a lot of people operating the modern data stack, the orchestrator is a missing critical component for them. And in fact, will be viewed as a necessary component of the modern data stack, as central as the cloud data warehouse, a transform tool, an ingest tool, and so forth. The other thing that happens beyond just the operational robustness is that we believe there is a critical technology missing from this picture, and that is this, Python. So Python, or more generally custom code, will always have its place in a mature data platform. While you can do a ton of valuable transformation with SQL in a modern data warehouse, there will be cases where you need to do heavy transformation or filtering before it arrives in the data warehouse, or have a custom data source that doesn't have a pre-built connector, or simply custom scripts that maybe maintain the platform itself. Engineers are very resourceful people who come up with all sorts of reasons to write code, most of which are legitimate. You know, after data arrives in the data warehouse, you'll again have valid reasons for turning to custom Python code. Machine learning workflows, for example, overwhelmingly rely on Python to create features and train models. Once those custom workflows become necessary, you'll see an exponential explosion in the number of dependencies that you need to manage. And it can quickly become unmaintainable if you're just using cron or ad hoc scripts to run and schedule those jobs. We believe that engineers should be able to wield and control Python transformations just as efficiently and conveniently as they're able to use dbt for their SQL. Orchestration as a general category has some baseline level of utility. Regardless of what you're using, your orchestrator should be able to easily sequence different steps in your workflows, as well as schedule and execute runs of those workflows. Explicitly defining the dependencies between your tools is generally less confusing and error-prone than having a wide range of overlapping cron jobs, each scheduling and executing a small part of your data platform. Orchestration also offers visibility into this execution. Generally, an orchestrator should offer a historical record of the runs that is executed, along with any relevant information about that execution. It should also be able to alert you in a variety of ways if something goes wrong. This in turn makes it much easier to learn about issues with your data without having to rely on a confused stakeholder noticing an issue with a query or dashboard. This would generally not be the preferred alerting mechanism. I want to talk briefly about what we think makes Dagster unique and uniquely suited to modern data stack practitioners philosophically. First, we believe that data platforms are built so that users can create data assets. That is why they exist. The pipelines we create are often responsible for creating or updating tables, models, external systems to reflect new information. And if these processes are orchestrated, it's natural that the central place to learn about these changes will be the tool that executes them. Similarly, we think your orchestrator should be intelligent enough to guide data from step to step for you. This tool that you use to run your steps should be smart enough to figure out how to pass data from one to another while generating useful metadata along the way. Next, the orchestration layer should feel like a boost in productivity, not an obstacle that needs to be worked around in order to execute your code. Dagster is built with the developer workflow in mind, with APIs that make it convenient to write tests that don't need to touch production databases, and a UI that makes it easy or even fun to work on and debug pipelines. Finally, because the orchestrator is often the only common component between the different technologies in your data stack, we see it as a natural system of record, not just for operational information, this run failed, this one succeeded, but for the structure of your data platform itself. Put more simply, it's where you define your data platform. One of the things we'd like to do with our data stack is to calculate a set of important metrics relevant to our company. To keep this simple, let's consider just a single one of these metrics, attribution. Metrics like this one require composing data from multiple data sources. Here, we need to incorporate information from our transactional database, purchase information, with information ingested from our ads platform, let's say Facebook, and our email platform, in this case, Marketo. For this use case, there's not really a need for any custom Python logic. We can do all of this composition in dbt as long as the correct data is in our warehouse by the time that dbt runs. The process of getting this data into the warehouse is managed via Meltano ingest jobs, which dbt can be said to depend on. If they don't run correctly, produce incomplete or incorrect data, then dbt will not produce the expected output, which can propagate errors through the pipeline. Trying to understand these issues becomes infinitely more complex without a centralized place to declare these dependencies. This code shows you how you might define those dependencies in Dagster. East ingest job is its own Meltano ingest command. And actually, we just found this open source integration that someone who is not us wrote, which is super cool. And we use that pre-built Solid to do the ingest command. Solid is our node of computation. And we use a pre-built Dagster DBC Solid to run our DBT project. Let's see what it looks like in Dagit, our tool for visualizing and running these pipelines. So now I'm going to go to a live demo, which is always terrifying. And this is just a demo. We've deployed that code that we showed. And here you can see, it's a really nice UI. You can see what's going on here. And then we've actually been running this on a schedule. So if we go to the schedule here, we can see that, for the past 14 days, we kind of started kicking these off. And so we're running these every day at 8 a.m. UTC time. And then if we go here, we can see our historical runs. And we have all this nice information. But actually, why don't we just go and run this live? So in Dagster as well, you can just kick off you can just easily kick off manually arbitrary jobs. And so now we're going to do that. This is actually going to run live on a K8s cluster. I'm really tempting fate here by running this live on our demo cluster. Just takes a second to pop up because it actually has to kick off some ephemeral compute resources in K8s. Give it a second here. There we go. And so now you can see it's kicked off the 3 jobs that are ingesting the different data. This is actually invoking Meltano, although we actually kind of faked it here because sometimes that can take a long time. And then afterwards, it kicks off a DBT job. And here we can just demonstrate a few of our features. You see this structured log that's occurring that provides you live debugging. Another interesting feature, as I mentioned, Dagster is very aware of data assets that it creates. So now that the DBT job is finished, we can actually go and search for what we call the asset materializations that have been created. Go here, and here are these events. And they've generated what we call an asset key. And this allows you, in this case, to keep track of particular DBT models. So if we click here, we can see the executions of a particular DBT model over time, understanding how long they took to compile in DBT, how long it took to execute, and so on and so forth. This is completely user pluggable, and you can insert your own metadata, which is super powerful. But at its core, if we go back to an executed one, we have executed a set of processes distributed, in this case, across a Kubernetes cluster, and ensure that they execute in the proper order and to completion. This is kind of the basic use case of an orchestrator. But let's imagine that we wanted to go further than that. And we've seen a lot of this with our users directly, where they start out with a sort of out-of-the-box traditional modern data stack, and they have an ingest tool, they run some SQL using dbt and a data warehouse, and then maybe they use a reverse ETL tool. But let's imagine that same team wanted to support machine learning. And this is why, and we have seen users do this, this is why we believe there will always be uses for custom Python data processing. Regardless of how powerful modern data warehouses have become, there will be times where it's more efficient or intuitive to do custom transformation or filtering before data enters that warehouse or afterwards. At its core, Dagster is a data orchestrator. In the previous example, we were looking purely at operational dependencies. We had a sequence of commands that needed to be executed in a certain order, but no data was actually passed between those commands. That was done, say, within the data warehouse. However, limiting ourselves to configurations such as these is quite narrow. Data dependencies are really important and can be difficult to manage in other orchestrators. Dagster has first-class support for passing data between different nodes in the graph. So let's go back to Yukon, right? We've ingested data from our different data sources, but to better serve their top customer, Yukon wants to use correlated information, say attributed purchases, to recommend products to their most influenceable customers. They've hired some ML people that work in Python and already actually having some custom scripts that written to take a batch of data and use it to train a model. Now they want to productionize it and get those same benefits that the ingestion workflow got. What's more, because this model is trained with data that is generated by dbt, it'd be nice if every time that a table was updated, our model also got retrained. So this is what this code looks like. It's just plain old Python. And imagine you'd written a Python script or you'd written Python in a notebook, and now you want to actually execute and do that data processing directly in Python. We think that this programming model where you write pure functions that take data and produce data with computation is actually philosophically very similar to the way that dbt models SQL. You can think of Dagster's transformation layer. And in fact, our users have articulated to this as what dbt did for our SQL, Dagster did for our Python. Furthermore, we actually have the ability to do more intelligent things in terms of run instigation. So in this case, we actually hook this up so that there's two different pipelines, one for each team, but we still want the machine learning pipeline to execute the instant one of our assets get updated. So in this case, what we've done is the teams have said, hey, whenever a certain table gets updated, in this case, add attributed purchases, I want to immediately kick off a new ML training job. And that's what they've set up. So we offer this capability that's integrated with our asset catalog that just says, whenever this key gets updated, please execute my pipeline. Let's see what that looks like in reality here. So I go to this ML pipeline here. One, you'll be able to see that the structure of the pipeline, and you can kind of witness the logical data structures that are passed between those different steps in the pipeline. So that's super powerful and really convenient. But you'll see here, it's actually attached to a sensor. And what this means, we just got it. This is actually polling and seeing when one of our asset keys gets updated. And you'll see that at 2:30 p.m., which is when I recorded this, it actually kicked off a job because the previous upstream DB job completed. And the moment that that table was updated, this kicked off. So two things have happened here. One is that an ML team has used the same technology and used Python to do data processing to construct a pipeline in Dagster using the same tools that you saw before. And then the two teams have been connected through an asset sensor rather than having an unencoded dependency or trying to slam everything into a single data pipeline. We think this asset sensor concept is extremely powerful because you can conceptualize the relationships between teams where their interface is itself a data asset. And I think this really falls in line with a lot of the talk that you've heard about data products. Data products are the relationships between teams. Dagster encodes that philosophy with a direct abstraction tool. So that's kind of the demo of Dagster and what we think about orchestration. I want to take the time next to kind of step back and talk about the modern data stack and where we see, we at Elemental and Dagster see it going. And you might have noticed that in this presentation, I sort of interchangeably use the term stack and platform. And notably, the name of this conference is the modern data stack. And I think it's worth digging into the difference between those two words. Is what we're building a stack, or is it a platform? We talk about this internally all the time. So first of all, what I want to do is define what a data platform is. It's really interesting because many of our users are on data platform teams or describe themselves as data platform engineers. But when you ask them, what is a data platform? You get a wide variety of answers that often don't make much sense. It's kind of a know it when you see it sort of thing. So we really spent a lot of time trying to more decisively and precisely, define what a data platform is. What we define a data platform are the tools, services, and applications that store, transform, manage, and serve data once it has left its original source or system of record. That's a big mouthful. I want to dig into two specific concepts here. One is the original source, and two, system of record. So an original source would be, if you're building a web scraper, the original source is the web itself. If you're using an ingest tool, you're ingesting from a system of record. If you're using data generated from, say, sensor buoys in the Atlantic Ocean, like one of our users does, the original source is that sensor buoy. So with that definition, we can actually tighten this up. And a shorter definition, simply put, the data platform is where data is managed outside of its native context. When you have ripped the data from its original location, ripped it away from the software that manages it directly, and the data itself has been the subject of the platform. That's how we describe the data platform. And I'm gonna say something that might be a little controversial, and I think it might go against a lot of the philosophies of some of the other vendors and folks here. But Dagster has a unique view of where modern data platforms are gonna go and where the modern data stack lies within it. One of our claims and beliefs is that the future is more heterogeneous than the conventional wisdom in the modern data stack community says it is. Meaning that, we think there's a certain view of the world where you just have an ingest tool, a monolithic data warehouse, DBT over that warehouse, reverse ETL tools, and BI. And that is a sum total of your data platform. As we've demonstrated today, you very quickly expand beyond the confines of that once you want to do anything custom. So we have a few different beliefs related to that. One, we believe that off-the-shelf ingestion tools will not cover all use cases. Engineers will always have the need to write custom code above that. SQL will not eat all compute. We are in sort of a SQL maximalist phase right now, where I think some people believe that Python and arbitrary code is dying and that SQL will take over the world. SQL should be used whenever possible because it is the ideal and most accessible language for data transformations. But we fundamentally believe it will not eat all compute. Similarly, data warehouses will not eat all data. And I think one of the interesting topics here, which wasn't really discussed, is that we have open source components of every phase of the data platform, but there's this implicit proprietary technology beneath the surface, and that is the cloud data warehouse. Most of I would submit probably most of the listeners here use Redshift, BigQuery, or Snowflake, all of which are completely proprietary systems. We do not believe that these, with apologies to those vendors, we do not believe that those data warehouses, especially monolithic data warehouses, will end up eating all data. And if any of these are true, orchestration will be a critical part, and we think the decisive part of data management going forward. So we think that the modern data stack, I skipped here, but so as we've described here, the needs of a data platform quickly evolve past a narrowly defined version of the modern data stack. It would be probably more accurately called the modern analytics stack, because for answering the basic questions about a business with off-the-shelf ingestion tools, there's a reason why it became so popular. It's the easiest way to do that. But the modern data stack is either going to have to expand to include more and more technologies, or it's going to exist within the context of a broader platform. Now, whether it's the narrowly defined version or whether the stack exists with the context of a platform or the definition of the stack expands, what we do believe is that the principles that make the modern data stack so popular and so effective for so many people will live on. And so we think it's important that an orchestrator lives along with that. So one is a reliance and a default towards managed services and a stack that is explicitly defined for the cloud era. To go back to a previous example, the dominant data warehouses today, the reason why they become dominant is they were redesigned from scratch with cloud architectures and constraints in mind, and they just work dramatically better for users. Second, you default to off-the-shelf tools when possible, but those don't cover all the use cases. And for everything else, you want to adopt an engineering mindset. I believe that the modern data stack frequently has been misinterpreted as a no-code or low-code movement. I believe that is not only wrong, I believe that is precisely wrong. The flagship tool of the modern data stack, or one of them, is dbt. The entire premise of dbt is that it has transformed analysts to analytics engineers, meaning that it has kind of upgraded their skill sets. And most importantly, even if they're not classically trained engineers, they have incorporated them into a software engineering process. So you try to outsource as much infrastructure work as possible to manage cloud platforms. But for the business logic, the stuff that describes the essential complexity of your business or problem domain, you should apply an engineering mindset to that. And with that, I will wrap up my presentation. My Twitter handle or any other platform typically is SchrockJames. And then please check out Dagster. Go to Dagster.io. It's an open source project. You can pip install it. And then we also have a very active Slack community. And thank you so much for listening to my presentation.
Hi, I'm Julia Schottenstein, and I'm a product manager at DBT Labs. In this talk, I'm excited to share with you more about DBT and how we enable data transformations. If you're not there already, head over to Discord, where I'll be answering questions live. You can also use this QR code to link to the channel. You can find me on Twitter at j_Schottenstein or email me at julia.schottenstein@dbtlabs.com. We just heard from Nick about how to use Dagster to enable orchestration. And now we're going to talk about what happens once your data has been loaded into your warehouse. Data in your warehouse is often still not in a useful shape for the business. You'll need to transform it to meet your team's needs, and that's where DBT comes in. DBT Labs was founded to solve the workflow problem in analytics. We created DBT, our product, so that anyone on the data team can model, test, and deploy data sets using just SQL. We have an open core product strategy. DBT Core powers the transformation, testing, and documentation. And we also offer DBT Cloud, which is a proprietary product to help teams develop and deploy DBT models with confidence and ease. I'll be talking about both in the demo a little later in the talk. So you might ask, what is happening in the data landscape that makes DBT more relevant than ever? The shift to cloud data warehouses changed the way transformations could be done. Data transformation used to be a lengthy and resource-intense process. Storage and compute for legacy data providers like Postgres and SQL Server were expensive, meaning most transformation had to take place before data landed in the warehouse. Cloud warehousing made storage and compute cheaper, which allowed transformation to happen in place. This shift from ETL to ELT is well talked about, but it created space for DBT to fundamentally change the analytics workflow. Now, data engineering teams don't have to decide what data is worth keeping because of cost and resource constraints. You virtually store it all in the cloud and let those closer to the business priorities decide how they want to model and shape the data for their needs. There are two predominant ways transform is done today. The first is with traditional ETL providers that offer a GUI interface for massaging data. The second option is custom Python code and orchestration. While both these methods have their strengths, they both share a common problem. Both methods require highly trained and hard to come by individuals to manage the data transformation process, which is not only expensive and hard to scale, but creates a workflow bottleneck. Those who can express business logic don't have the tools to do the transformation themselves. And these analysts become reliant on the smaller, more specialized group to produce clean data tables that they can then analyze. This ultimately makes the data workflow process slower. Lots of back and forth requests, a lot of miscontext, and the frustration of getting the data in the right shape often leads to teams giving up prematurely and settling with less than ideal outcomes. DBT solves this frustration and fixes the data workflow problem. SQL is the language of every modern cloud warehouse, and it also happens to be known to analysts and engineers alike. By creating a solution that leverages modular, portable SQL, we're making transformation both faster and more accessible to more people on the data team. More hands, lighter work. But it's not just who is transforming data, it's how. With rigorous testing, version control, continuous integration, and automated documentation. These processes are critical to ensuring data code quality and scalability. Software engineers have been working like this for years. We just made these principles applicable to data. And so while transformation is at the core of what we do, we're a platform that lets you develop, test, document, and deploy your data models. We push all compute down to the data warehouse. Why is that so important? Our architecture is way more secure because data never leaves the warehouse. And two, with transformation in place, no added network latency, you can expect faster operations. We're also heavily investing in metadata because anything and everything you'd want to know about your data is exhaust for DBT. We want to use the metadata exhaust that DBT generates to help data teams respond to data incidents, understand provenance for data sets and their use cases, address performance and quality improvements, and more. As the producers of these data sets, we are in a unique position to both observe how logic is changing and how data is changing. As a result, there's a lot of context and insight we're able to provide both data teams and data consumers. dbt's development framework promotes 4 key outcomes. The first is collaboration. At the core, we believe in version control and documentation, allowing for smoother handoffs and teamwork. Velocity. With dbt Cloud, we handle all the deployment for you. Focus on analytics and use cloud to ship data products faster. Quality. Testing is done right alongside code development. Never make quality an afterthought. And finally, better governance. We help teams standardize processes and control access to simplify compliance. dbt promotes a new way of working. It empowers data teams to move faster and more reliably with some simple frameworks and guardrails. Congrats, you're now an analytics engineer. These are the humans operationalizing the data workflow. But don't just believe me. This is what one of our customers, HubSpot, is saying. We think empowering analysts to own their tools is the only way to build a productive analytics team at scale. dbt makes it easier to do data modeling the right way and harder to do it the wrong way. Okay, enough pontificating. Let's see dbt in action. We're going to head to the demo with an example e-com shop, Yukon, that we've been referencing throughout these talks. Okay, demo time. So what we're going to actually do now is build some dbt models so you see how you can do transformation in some of the analytics engineering workflows with dbt. What we're looking at right now is a dbt project in our cloud IDE. So our dbt cloud IDE is a purpose-built IDE that makes developing dbt really simple. For this demo, we're going to be working on our Yukon shop, which is a fictional e-com company. And the first thing we want to do is really get familiar with their data table so we know what we need to transform. Okay, so let's take a look at some of the base tables that we're looking at. So we have a users table called staging users, which is pretty simple. It's user ID, first name, last name, email, language, activated or not. We have a purchases table, which is going to link a purchase. It's going to create a purchase ID and it's going to link a user ID with an item that user purchased on an order date and give it a state of whether it's successful or not. And then finally, we have a staging items table, which just is going to give a little bit more detail about the kind of items that you can purchase from Yukon. So it's an item ID, category, and the price. So these are our base tables. We have very light transformations that are happening here, like a rename of a column, but it's pretty close to the raw data. Let's look at our lineage tab. This is one of the great features of the dbt Cloud IDE. When you're developing with data, sometimes you can get lost in the DAG. You forget what models are downstream or upstream from the model you're currently building. And this helps you orient if you're creating a new model or editing a model, where exactly you are in the DAG. So we have this customers table. Let's take a look at that. That's actually a little bit more of a complex table. And it takes in the 3 tables that we just described and does some transformations. Okay, what's going on in the customer table? We have a user ID, first name, last name. Then we have a first order, the most recent order, a number of orders, and customer lifetime value. We can see here in the code, what's happening is dbt starts pulling in our base tables, their staging tables, using this ref function. That really powers a lot of the DAG creation in dbt. It's a Jinja function, which basically says the table I'm building right now references these upstream models, staging users, staging purchases, and staging items. And then it does some transformations looking at min, max, and count of the order dates and purchase IDs to create these new column names, as well as aggregating all of the prices for the purchases that you've made to get a total amount, which is your customer lifetime value. So that was a really quick overview, and we're going to actually create a transformation together so you get a better feel for how it all works. Okay, you can see right now I'm on the main branch. At the core of DBT is version control. And if you're new to Git, DBT Cloud's IDE makes the workflow around Git really simple. So it gives you guardrails, so you practically can't do anything wrong. So we're going to create a new branch. One of the tables I think might be interesting is looking a little bit more on what our most popular items are. So we're going to create a new feature branch called feature items purchased. Now we're on a new branch that we can do our development work. And in our DBT project, this is our models table folder where all of our models sit. Staging is the base tables, and the more complex tables, we can add them here. So let's create a new file, and we'll call that items purchased .sql. It's a SQL file. Okay, the first thing we'll want to do is pull in our upstream models that this model will rely on. So let's pull in the items table using that ref function that we just described. Curly brackets means I'm referencing Jinja. Okay, that looks good. Now we want to pull in our purchases table in the same way. Okay. And now we're going to do the actual transformation. So we're creating a new table. We'll call it items purchased. And let's select the columns that we want to show in this table we're building. So we'll want to pull the item ID as the unique identifier. Let's also pull the category for the item. And let's pull the count. So the number of times that this item has been purchased. We'll call that column that we just created total number purchased. And then let's pull in the sum. So the total of the prices, so we know how many times, how much it's been transacted. We'll call this total amount purchased. Okay, and we're calling that from the items table. We're going to join that with the purchases table on the item ID. Item ID. I just realized another mistake I had here. Okay. And the last thing we want to check is that the state is actually successful, and we don't want to include purchases that weren't successful. And we'll group by 1 and 2. Okay, take a minute to see if that looks right. And if I make a mistake, DBT will let me know. Finally, we're going to select star from that table I just built, items purchased. Okay, let's see if this compiles. Awesome. Okay, so we have a new table that we've built, has the item ID, the category, the total number of times it's been purchased, and how much has actually been spent on that particular item. We've now created a table that might be useful for your business to actually know which items are performing better or which ones are performing worse. And we're a step further from the raw data to actually be aligned with what the business needs. And here's our DAG of the new table that we've created. So once we feel good about that, we can commit our work. I'll call this new items purchase table. And we open up a pull request. This is the Git flow simplification that I was talking about. So now we're in GitHub, we can create our pull request. And one of the cool things about dbt is it has this like little check mark here. So it's checking to make sure that the code that I just created passes all of the tests that I've also set for my data models. I'm going to take a minute to actually show you what that looks like in dbt. So along with transformations, we also make documentation and creating tests really native as a part of the dbt project development work. And so let's take a look at the schema.file. Schema file is a config file where you can give your models descriptions, you can give more descriptions on individual columns, you can create tests, making sure an ID is unique and not null. You can also make sure that one of the values is an accepted value, and get a lot more sophisticated with just creating tests to make sure the data is as expected. And that's really important because we want to make documentation and tests a native part of the development and workflow when you're building data models. dbt makes it really easy to see all this visually too in a doc site. Here, it will describe all of your models. You can get a nice description of the table, the columns, what are the downstream dependents, what are the upstream dependents. You can see a nice DAG here as well. And so once you've defined and described everything within your dbt project, we'll get this nice doc site that gets generated as well. So one of the things that I've been doing behind the scenes is I created a CI job that will make sure that this new model that we're building passes all of the tests that I've described for my for my table that I've just built. And in this pipeline for our GitHub, we see this little check mark from dbt cloud that says, yep, we've tested the data. There aren't any mistakes in it as you've described, and it's okay to go ahead and merge your pull request. Now, if your tests fail, you'd get an X here, and it wouldn't be possible to merge your new code into main. This creates a little bit more confidence. That way your data is building as you expect. But in this case, it is, so I'm going to merge it into my main branch. Okay, great. So once we finish building our dbt project, the next thing we have to think about is, well, how do we actually deploy that code on a consistent schedule? dbt cloud lets you do this with a few clicks as well. So we can see we have two environments set up for this project. We have a development environment, which we were just working in, and a production environment where our jobs are going to run on a consistent schedule. So if I look at my jobs, I have a production run job. And with just a few clicks, I can describe the commands of what I actually want this job to do. I want it to seed all of my data, run the full DAG, test that DAG, and it's going to run on a cron schedule every day at 9 a.m. This is really simple, and I can have lots of jobs to build certain models that I care about on different schedules. And now you don't need custom engineering work to put your code into production. Let dbt cloud do the hard work for you. And so these are the things that I think are really fundamental to understanding how DBT and DBT Cloud works. The last thing I wanted to showcase is there's also really great isolation built into DBT. So this is my cloud data warehouse. We're using BigQuery in this example. And when I'm in development mode, all of my tables are building in isolation under this DBT Schottenstein schema. So I can't possibly mess up any of my production workflow because everything is building in my own sandbox here. Yukon Analytics, these are my production tables. So with DBT, I'm able to create separation of environments within my data warehouse. So that way I can create dev environments for each of my devs, staging environments, so you can make sure that everything looks really great before you kick off those jobs in production. And finally, an area where these are really reliable tables that can be consumed by dashboards or other visualizations ready for your employees or internal uses. So that's it for the demo. In a really short period of time, we were able to show a bunch of cool things. One, how to do core DBT transformations with DBT Core, how to add documentation and tests your models, how to look at CI, so that way when you merge code into your production main branch, you make sure you haven't introduced any mistakes, how to set up a job, and then how we create isolation between different environments and different developers in your warehouse. And that's it for the demo. We're going to head back to the slides to wrap up the presentation. There's one thing I hope you learned from the talk. It's that DBT isn't just software. It changes the way people work. With DBT at the center of your data stack, you can be sure your teams will be more collaborative, working faster, all while removing bottlenecks and shipping more reliable data. It's a fundamentally different philosophy on the way data teams think about data ops. One thing we strongly believe is the world needs more purple people. What do I mean by that? This metaphor paints a world where humans with a deep understanding of business context in a particular domain are called red people, and humans with a breadth of technical expertise are called blue people. Purple people are the people in between. They have a little bit of both that enables them to translate between red and blue. Analytics engineers are purple people and a critical Sherpa of guiding companies to the promised land where data actually helps teams make better decisions for the business. And we're well on our way to making DBT the standard. We have over 6,000 companies using DBT, over 1,000 customers, and more than 18,000 fantastic members of the DBT Slack community. We welcome you to join us. DBT Core is open source and free to download and get started. We also have a developer tier for our DBT Cloud platform, so any individual can try out the full platform for free. Some other ways you can get involved: join the DBT community Slack, subscribe to our Analytics Engineering Roundup weekly newsletter, listen to our podcast that our CEO, Tristan Handy, and myself co-host every other week. And lastly, we're hiring, and we'd love to hear from you. And that's it for me. Again, I'm Julia Schottenstein from DBT Labs, and I'll be sticking around in Discord to speak with all of you. Next up, you'll hear from Max, who'll be talking about Superset. Thanks very much for listening.
Oh, hey, hello everyone. My name is Max, and today I'm going to be talking about Superset. But before I jump into it, I wanted to just share a little bit of my excitement around the conference. As a user of open source data tools and as an actor in different communities and as a builder, just really excited for this this conference to come together and for people to have the opportunity to talk about what they're building and all the open source data projects that are emerging nowadays or maturing. I think it's going to be really interesting to hear more about everything that's getting built in this space. So let's jump right in. Today, I'm going to do a quick intro of who I am, talk a little bit about open source BI, talk about Superset. We'll do a demo, and then and all of that within about 20-25 minutes. So here we go. So quick speaker intro. So my name is Max. I'm super excited and passionate about building open source data tools. I've been building data tools since like for my whole professional career, which is like probably 20 years plus at this point. So I've been working with that through different generations of data tools and building stuff. At this point in my career, I'm most recognized for the work that I've done as the original creator of Apache Airflow, so which I created while at Airbnb in 2014. And soon after that, so I think it was less than a year in after I joined Airbnb as a hackathon project, I started Apache Superset, which I'm going to talk about today. More recently, so in 2019, I started a company called Preset. This is a commercial open source company around Apache Superset. So our mission is to make every team a data team. And the way that we're approaching this, and at least in this phase, is by offering Superset as a service. So I'll let you know a little bit more about this towards the end of the presentation. But for now, I will jump right in and talk about Superset. So first, I wanted to talk a little bit about this blog post that I wrote a while back, not so long back actually, about the future of business intelligence being open source. So the general idea of this blog post was to take all the reasons why open source has been disruptive and great and successful, and to apply that to the space that Superset is in, which is the business intelligence space, and see how it applied. And it turns out it applies very well, right? If you think about some of the core reasons why open source has been successful and why Superset itself, can be has been successful in business intelligence. Let me decompose that fairly quickly here into a series of points. So the first one, I think, to me, or one of the first one, is avoiding vendor lock-in, right? These vendors, these enterprise vendors that have been around for quite a while in different spaces, but namely in the business intelligence space, when they lock you in, you're kind of stuck with them forever. You can't contribute necessarily back. It's really hard to customize the tool, to extend them, to integrate them with your stack. So that was actually one of the premise why I started Superset when I was at Airbnb in 2015. The fact that we were using all sorts of modern technologies like Apache Druid and Presto that didn't work so well with the tools offered on the market at the time. I think since then, these tools work well with the databases we had chosen at that time, but I think they often are a few steps behind in terms of connecting with the latest, greatest tools that people are using nowadays. Another point, I think, is just the power of a community. So when everyone gets together and build things together, and when everyone can contribute, and not just by contributing code, but by contributing questions and answers and extensions and plugins, I think everyone wins, and open source really welcomes these contributions from all over the place. And there's really a lot of power that comes from a very engaged community. So we certainly have that in our community. And that's a trait of thriving open source communities. So for these reasons and many more, I believe strongly that the future of software is largely open source and the future of business intelligence and data visualization, data consumption as well. A bit more on Superset. So I mentioned a little bit the story of how Superset came to be. Nowadays, like many years later, so about 5 or 6 years later, Superset has established itself as a very successful open source project, certainly one of the most popular one out there, and certainly in the space that we're in. So the community is thriving and growing. Ourselves, at Preset, are investing a lot in making this product and this community successful. So what is Superset? So really, it's a business intelligence tool in many ways. It's a data visualization, data exploration platform. It allows you to explore your data, visualize it, assemble dashboards, connect to pretty much any SQL speaking database, share with your peers, share with your team, your visualizations and dashboards. So you'll see that in much more detail in the demo, but that's a quick overview. Why people love Superset today. So it's kind of one-stop shop for everything data visualization and business intelligence. So you have, dashboards, a code-free Explorer, as well as SQL IDE. So under that, under these different portion of the product, you can pretty much solve all of business intelligence use cases. It works well with all the modern data sources and all the not so modern ones as well. So pretty much every database out there that can take analytical workloads work very well with Superset. We got tons of visualizations that people can select from. It's an extensible platform too, in that sense, where people can create new visualization plugins. So there's all sorts of visualizations that exist today, and if the ones that exist are not to your likings or to your liking, or if there are some missing one, it's pretty easy and doable to create a new visualization for Superset and share it with the community. This is extensible and scalable, so very much a cloud native type infrastructure. So runs, in Docker and Kubernetes, made out of bits and pieces that people know how to productionize and run at scale. So you can definitely take control over that. There's a lot going on here. I won't read through all of this, and some of it you'll see in the demo. So I want to go kind of quickly, but we have dynamic dashboard, custom Vig plugin, a nice semantic layer. We do support all sorts of visualization. There's good caching to relieve some of the load on the underlying database. We've got granular permission, RBAC security, so role-based access control, as well as alerts and reports. So if you want to schedule some reports to be sent via Slack or via email, you can do all these things and more in Superset. So the list of feature is very rich, and that's kind of what's expected of modern business intelligence solutions today. Lots of companies are using Superset today in production. So those are just some of the logos. We have a page on the repo, I believe it's somewhere called, it's called In the Wild, that has the self-reported companies and organizations who use Superset today. This list is growing quickly and pretty much every day. So we can only assume that this is the tip of the iceberg, and there's a lot more companies that are getting tons of value from using Superset. I'm going quickly through this slide here. So that's a one view on the architecture of Superset, saying that essentially we have this cloud native architecture, that it's essentially a certain load of web servers and async workers running Celery with some caching, message but I won't get too deep into that today. I'm going to focus more on the demo and looking at what is Superset and how does it work and what can it do. We support all sorts of databases. I mentioned this already. So these are some logos. I think we go way beyond that, and the extensibility is the beauty of it. So you can write your own drivers as well. We use an underlying Python package called SQL Alchemy to do this. So it's fairly easy to write and extend more drivers. And because of that, that's the reason why we have all these drivers today, because we're in the Python ecosystem. All right, so let's get into the demo. So I'm going to go fairly quickly through this too, knowing that I'll give you some instructions if you want to go and run this on your own and do your own test with your own data. That's going to be much more interesting. But I wanted to give you an overview of what it looks like and feels like to work with Superset. So here we just happen to be on the preset platform because that's probably the easiest way to run Superset today. So here, disregard the logo on the top left. If you'd be running the open source version of Superset, you would see a Superset logo here on the upper left, and maybe there's a handful of bells and whistles that you might not, that you'll be able to see in this presentation that you wouldn't see in that context, but it's pretty much pretty much the same experience, right? So at preset, we run essentially vanilla Superset with a little bit of ice cream on top. So for giving you a quick tour, and I'm going to go quickly here. The goal is not to explore all the features. I'll show you the big chunks, the big parts of Superset. So here we're just looking at a simple dashboard. So that just happens to be a generic sales dashboard with tabs. Here, I don't think there's any of the dashboard level filters that have been set for this dashboard, but you can have these interactive components of selectors and sliders and filter handlers to interact with your dashboard. There's some amount of cross filtering and actions of those. I don't think they've been set up for this specific dashboard. So I won't get into this, but I'm going to go here from the dashboard. I'm going to skip the dashboard editor too, but there's a dashboard editor here that if you click in the dashboard editor, you can add more charts, and you can add different sections and tabs and the things you would expect out of a dashboarding type application. Now I'm going from the dashboard into what we call the Explorer or the no-code Explorer. So here, whether you speak SQL or not does not matter, where you can easily here drag and drop. Also say if instead of breaking down by product line, I wanted to group by say country, I can easily just drag and drop. I could apply a filter here. So if I wanted to filter on a specific product code, I could do that pretty easily here. And then here you can run your different queries. You can pick off of this visualization picker, whatever visualization makes sense to you. So here is the place where you select the visualization type that you want. You pick, what kind of time filtering and time grouping you want to do. So where you define your metrics and what you want to group by through drag and drop, or by clicking here and selecting the metrics and dimensions you're interested in. These visualization you can then easily assemble and save and share. You can assemble inside dashboards. I'm going to flash very quickly our semantic layer, which is kind of what Superset knows about the underlying database. So Superset understands the data structures. So you point it to a table or view or a SQL query, and then you can add calculated columns and metrics. There's a variety of settings that you can set, but essentially this is our simple semantic layer where you can add pretty labels and nice description for your fields and metrics. So going quickly through this, very much on purpose here. Here there's behind the scene, Superset is generating these queries, right? So you can view the query that Superset is generating behind the scene. And if you're interested, you can also, or if you want to go deeper and do perhaps more advanced things, you can also spin off SQL Lab. So SQL Lab So we looked at dashboards, we look at our no code explorer. Now we're looking at SQL Lab. So SQL Lab is a simple SQL IDE. So here I can navigate to whatever schema. So I think here we were looking at sales data. I believe that's the table we're looking at. So you can navigate your schemas and you can author arbitrarily complex SQL, run your SQL. It's also possible here to visualize your result, to kind of go back to where we were before. So I could have modified the SQL, write some complex ratios and subqueries and whatever SQL makes sense. And then it's possible to go back and visualize those results. So the super high level, this is what Superset is about, right? I didn't show everything. Maybe I'll give a peek here to some of the menus without necessarily going too deep into them, but this is in the settings menu is where you would set your different access roles and your role level security. We have this notion of annotation layer for time-based annotations. You can manage CSS templates if you want to style your dashboards. We have these alerts and reports, or if you're interested in delivering scheduled reports or alerts via Slack or email, you can do that here fairly easily. And on top of that, you know, there's a handful of other things, other small features where you can upload CSV. You can, you know, configure your databases and data sets, as I showed a little bit before, and you can look at collections of charts and dashboard. And there's also this home screen where we started this demo from. So with that, I'm going to go back to my slides and wrap up. My goal was to keep this demo like a very quick tour, you know, like a 5 or 10 minutes tour. So with that, I wanted to talk a little bit about preset. So we love for people to join the community, the Superset community. So I encourage you to go to our GitHub and to the Superset GitHub, and there's tons of resources there. You can install Superset, use Superset, get involved in the community, ask questions, get involved. So there's tons of resources there. I wanted to mention preset because I believe it is very much the best way to get started in Superset. So if you're interested in just testing out Superset and checking it out and connecting it to your data, you can get started in literally the next minute or so. If you want to go the open source route, this is totally great too. And we're trying to make that as simple and easy to get onboarded on Superset as it is with preset, but it's a little bit more involved to go and to install Superset and get it to run. So I encourage you to go to preset, where you have pretty much all the features that you get out of open source Superset with some extra on top. And we do offer a freemium distribution to Superset, so you can get up to 5 users, kind of unlimited. With some of the features are limited around security, role-based access control, and just the number of users you can have. But this is totally a great place to try and get started with Superset. As always, you know, you're not locked in with us as a vendor too, so you can always pivot and decide to run Superset on your own now or later. So that was the little bit of commercial bit here about presets. I won't go too deep into the commercial offering here, but these are some of the items that you get out of preset that you may not get out of the box out of just open source Superset. And with that, that's mostly a wrap for my talk. So highly encourage people to go and try Superset and get involved. The modern open source data stack is really coming together, and we're really excited for Superset to be that consumption and visualization layer on top of it all, and very excited too of all of the applications and other layers that we integrate with, and that you'll probably hear about in the context of this conference. So thank you, everyone. And then I believe I will be on the chat after this. So I'm not sure if it's a Discord or a Slack, but I'm heading there. And I'll be there to answer questions and to talk about everything Superset and open source data related. So thank you, everyone. And see you on the chat.
Hello and welcome to the last talk in the Open Source Data Stack Conference. Our data is on its final leg through the modern data stack, and now we're going to talk about putting it to use in our operational tools. As with the other talks, feel free to join us in Discord, and we can continue the conversation there. I'm Brian Leonard. I'm the CEO and co-founder of Grouparoo, coincidentally, an open source tool that helps you operationalize your data. Before that, I was technical co-founder at TaskRabbit, a way to get chores done in your house. While there, I became super passionate about solving this gap between our data team and the teams that were working with customers, running the business out there and getting them the data they needed to be successful. Super happy to talk about how we can help everyone with that here today. Let's review of where we've been through the journey so far in the conference. So we've loaded data into our data warehouse with tools like Snowplow and Meltano. We've transformed it according to our business rules with tools like dbt. We've presented that tools to our users, that data to our users with tools like Superset. They can see reports and graphs and gain insights and all the stuff we've learned. And you'd think they'd be happy. They see all their high value customers, for example, and now they know who they are and they can target them, right? Unfortunately, the more data you get, the more you want to do with it. The next stage that you'll inevitably start seeing after you get your act together with all these great tools that we've talked about so far is putting that data to use back in the tools where those teams live. Your support tool, your marketing tool, your sales tool, et cetera. That's what we're here to talk about today. If we remember UConn's goals, they were about having a better experience for their high value customers. Can we enroll them in an awards program so that they know we're glad to have them? Can we give them a better support experience? And can we, continue the conversation on social media? What that means from a data engineering perspective, really, is that we need to teach Marketo and Zendesk and Facebook some of the things that our data warehouse knows. And we need to do that to be most effective. We need to do that automatically and seamlessly for the business. This is called reverse ETL. When we talked about ETL before, ELT in Meltano's case, in general, it's about getting data into the warehouse. Reverse ETL is taking that data from the warehouse and putting it back into some of those places that we dumped it from before. So how can we write from the data warehouse into our operational tools so that our business teams can use that? Why would we want to do something like that? We want to increase their efficiency and effectiveness with this data. Now, as James talked about, they're probably already doing this one way or another, usually through favors from the engineers and almost always with CSVs. Like, this is happening because the data is super important for them to be able to do their jobs. The opportunity we have in the modern data stack is to do that the right way, from our single source of truth with our data warehouse being automatically fed into those tools so that everybody wins. How does this work with Grouparoo? We teach Grouparoo who our users are, the data that needs to get into those other systems. For the use case that UConn has, we also teach it what it means to be a high value customer. And then we sync that user and that definition into the tools that we're using, Marketo, Zendesk, and Facebook, in an automated way. Let's take a look at how that works. Let's start by showing our end goal, getting all of our users into Marketo and the ones that are high value tagged as such that we can send them a special promotional email. So in Grouparoo, that means creating a destination. So we'll call this Marketo, and we'll say, let's sync over all of our users just as they are in the data warehouse. Who are we going to send over? Let's send over everyone that we know about with an email address. Teach Marketo what its email address is, their first name, their last name, and then we can set anything else in Marketo, but we don't need to send that much more data to accomplish our use case. So step by step. Critically, we'll tag them as high value so that over in Marketo, we can treat those high value users more special. We save it, and then Grouparoo starts to do its thing. We're going to verify all of the data, make sure it's right and fresh from the data warehouse, and then start syncing to Marketo. We use Marketo's batch endpoint, so it should be pretty fast. And now we can see who we synced over. These are all of the different users that we synced over to Marketo. We can use this to gain confidence in what we've sent, as well as know exactly what Marketo knows about all of our users. Of course, we could also look in Marketo and we'd see all of the users there are sent over, and this list here exists, the high value users. So for example, Alice is in the high value user group, and now she's in Marketo, and we can use that to talk just to those people when we want to send them special promotions. Now, that's the end goal. Who are our users? What do we know about them? What's the special segments that they live in? And then teaching Marketo about them. Let's see how we got to that spot. These, of course, come from our Snowflake database. So the thing we have to do there in Grouparoo is to create a source that comes from Snowflake. In this case, we're going to import the whole table of users and know everything about them. So we choose the users table here. We see that these are the right people that we want to import. And we teach it what our primary key is of these users. So in this case, it's the ID of the users. That's a property that we're going to call user ID. We're going to know that to know who is the unique people in the system. We then show it how often we want to update those users and keep Grouparoo and therefore Marketo up to date. So we're going to say, let's do this every 15 minutes, check for new users, and we're going to pick this updated at column so that we can do it incrementally. Grouparoo will remember the last highest timestamp that we loaded users from, and because our table has it, we can use that to be super efficient with how we detect changes in this table. Next step, let's determine what data we want to load in from that users table. As we saw with Marketo, what we're going to need is the first name and last name and email, but we can click as many of these as we want to load all of that data in case we needed it from Marketo or some other destination, or to use with our segmentations. When we do that, we have all of these properties, and the data will start to load in, and we'll know everything that we need to know about these users. We can look at them, see how if the data looks right. For example, this user here, here's what we know. And we are loading all of that correctly. Now, maybe that's not everything. Maybe we didn't use DBT to wrap everything up and transform it into a single table, in which case we need to pull in data from other places. For example, we can pull in purchases here if we need to, connecting to the purchase table and pulling in the lifetime value. To do that, we need to say who the user, how the purchase table maps to the users we know about, and add a lifetime value property into Grouparoo. In this case, it's going to be a number that comes from the price, which we sum up, and we're going to say only sum up the purchases that are successful. So for example, maybe they weren't returned or something like that. When we do that, this user will get 62. All of the other users will get imported, and we'll see that all of our users now have a lifetime value on their profiles. This user is not high value because he's 90. The marketing has defined high value as $100 or more spent. And so now it's time to go in to do that, define what that group looks like. We do that with groups. One group that's already here is everyone with an email. Groups can be complex rules or simple rules. The ones we're doing today are pretty simple rules. In this case, it's everyone with an email address. We can add that high value one by going in and naming it high value and saying that it's everyone with a lifetime value that is greater or equal to 100. We'll very quickly know who all of the users are that meet that criteria. We can browse them and see that there's these 100+ people and what they look like, and that they're in these certain cohorts in these groups. With those groups defined, we're able to send them to Marketo and do everything that you saw before. If somebody newly makes a purchase, we'll detect that they need updating. Now maybe they're 100, they're over 100 in lifetime value, and they'll get added to the list in Marketo. The power starts to come here when we add in other destinations. And so we did all this for Marketo. We can now reuse our data warehouse data and these same definitions of our users and our cohorts to, for example, do our second goal, which is to update Zendesk. So those same high value users, we're now going to sync them over to Zendesk. We'll do the same thing. We'll sync everyone that we know about that has an email address so that when they email in, we'll know all about them. We'll teach Zendesk about their user ID and their name and their email. We're pulling in all the custom fields from Zendesk so we can set any of these if we wanted to. And critically, we'll again choose the high value group here so that in Zendesk, they'll get tagged as high value. Save that. And same idea, Grouparoo is now syncing over to Zendesk, which will get all of those users over there in and critically tagged as high value. Here's all of our high value users. What it means in Zendesk's specific case, when a user is tagged as high value, any tickets they create will be tagged as high value, which allows us to create a rule to route that to a queue that'll then be worked faster. This accomplishes, the second goal we had, which is giving them a better customer support experience. Finally, we had one other goal, which is to teach Facebook about these high value users. So same story over and over again, reverse ETL at work, leveraging that data that we have to teach Facebook with their email address, in this case, about our users, creating an audience over in that system so that we can remind them that we exist and that they love us and they should buy more. We can send over any users we want. Every group that we pick here will become an audience in Facebook. See, here we go, audiences. And that allows us to either talk to them directly via ads and other, or to create a lookalike audience such that we can find more high value users. And that's how it works. You let the system know what data is important to you and what it means to the business, and you map that into the tools that your teams are using. They'll automatically see the new data as it comes in the tools that they use every day. It's never been easier to be a data hero to these teams that need this data so desperately, and now we've made it so easy. I thought I'd take some time to talk about the trends we've seen throughout the conference, how they apply to Grouparoo. The first is about owning your data. The second is about data teams delivering data products, thinking about it in that way. And the last is about doing this through software engineering practices, through data ops. I realized when I got to this point in my presentation that I only really used this one template, 1, 2, 3. I heard somewhere at some point that that was the way you're supposed to do slides, and that seemed pretty good. I showed this to some people in the data space, and they said, no, this is too boring. What you need are memes. People in the data space love memes. I said, I don't know anything about memes. And they said, it's not hard. You just take what you want to talk about and Google it. And I said, okay, so I guess I'm gonna do that. So you want to own your own data. Am I doing this right? I don't know. So you want to own your own data. This is about controlling your world for agility, compliance, better decision-making. We're putting all of our data inside of this warehouse that we have control over instead of some external vendor. That allows us to not have vendor lock-in and to query and debug and make use of it in ways that we haven't thought about yet, but will. We can iterate more quickly because of that. It's all in that one place. There's no new ETL to do. In this modern data stack, we can plug in all of these tools that operate out of that data warehouse and put it to use. And we have a single source of truth that we can share between all of the consumers of our data. The BI tools are seeing the same data definitions, literally the same tables and columns, as our reverse ETL tool, which is then interfacing with all of our external vendors. And so that's a unified decision-making, customer experience, everything is all brought together because of that architecture. In Grouparoo, this also means sharing the same definition of what it means to the business between all of those vendors. And so we have the columns that are shared in the same way. We can add in these definitions in our segmentation. They be shared amongst all of those different vendors. And so the customer experience is seamless and we don't have any errant, weird bugs happening with those experiences. Taylor talked about thinking about what we're doing as delivering data products. There's this opportunity as data is more and more important and these data teams are evolving, is to set our own data vision for the company and how it impacts the whole business and to be a competitive advantage. Specifically, we're seeing teams pushing forward from just providing CSVs to creating business intelligence and directly impacting the customers. One way that people are impacting customers is the insights into our business being fed back into the products. That's an example of an internal integration. Another is reverse ETL use case where we're syncing that data into, say, marketing tools. This is now a core part of the customer experience. And that's more impact than data teams have had in the past. And is a very exciting development in this space for sure. In order to do that effectively, we need to embrace collaboration across the whole organizations. How can marketing teams and data teams work together better? And I think it's exciting they can be about the shared definitions of what this data means. We can all really understand what it means by looking at it together. Something we're seeing in Grouparoo is the data team providing that foundational knowledge, building on top of everything we've shown in the data warehouse. Here are the properties of your users that you really care about. Their email and first name and lifetime value and likelihood to churn and all these kinds of things. By having this tool that allows us to browse these profiles, understand if this looks right, we can sit with our marketing counterparts and see if it looks right. And then we can actually hand it off and say, all right, it's now your job to define what these cohorts look like. It's your job to do whatever you need to do to be successful, mapping this into your tool like Marketo. This gives them the autonomy they need to be successful. If they need new data, we've already shown a stack that allows us to be agile to get that new data to them. And it's all so much better than the CSVs that are already happening in our organization that are out of date the minute we export them. This allows them to define what they need and have it automatically kept up to date in those systems in a much better way. But because of all this, we're directly impacting customers, which is great. we need to think more about the software engineering practices put into play in the data world. This is another trend. It's about using the learnings we've had from agile software development over the last 20 years in the data space. And so we're seeing more iterative development. You finish that DBT model, or even one column of that DBT model, and you can push that up to get feedback and deliver value immediately. You don't have to wait until the whole dashboard is done. We see that kind of stuff getting checked in as code into source control so that we can go through the whole life cycle, pull requests, tests, continuous integration, staging environments, and on until it's deployed into production. The benefit here is that we get more eyes on the problem, we create organizational learning, and we keep it under control because now we're directly affecting those customers. We don't need to be sending out 10 million emails to every user of HBO. We can use these practices that are tried and true to be successful. It's a much better demo to show the UI, but everything that I showed at Grouparoo can also be saved as JSON files to go through this software engineering Git-based workflow. So you can check your definition of your lifetime value into source control, see that as a PR, have tests that verify that it works as expected against sample or real data, check that in, have it automatically run in continuous integration, see things working in a staging environment, and then deploy it. And that workflow is going to be more and more common in the data world. And it's just so much better for moving quickly and delivering value at the level that the data teams are now than, say, Python notebooks or crazy SQL file on a data analyst's desktop. These are the trends that we're seeing. Oh, I feel so much better now that I'm back to my tried and true template here. It's really great. So these are the trends we're seeing. It's about owning your own data, data teams delivering data products, software engineering practices. You've seen that throughout the conference, and that's what I have. Oh, okay, one more meme. Sorry, one more meme. Grouparoo has a free trial. If you want to check it out, go to grouparoo.com and check it out. Now I'm done. Thank you. That was operationalizing your data through reverse ETL. Head on over to Discord if you want to chat more about it. We'll be there and we'll be ready to answer any questions. Since I'm the last talk through this whole data pipeline journey, I want to thank all the vendors that have presented. It's really great people doing really great work that enable organizations to produce data products that they've never been able to do before. And it's so great that we've been all together and we can help UConn move forward. Tomorrow, we have Emily leading a roundtable, talking more about open source and this world. That'll be the finale of our conference. I hope to see you there. It's going to be great. Thanks.